In this video, we're going to try to explain how you can identify isomers quickly. And so before we can dive into that, we need to be able to recognize the pattern that there are for all alkanes, alkenes, cycloalkanes, alkynes, and cycloalkenes. So this is butane, and butane has 4 carbons, and if we count them, they have 10 hydrogens. And so for an alkane, our general formula is CnH2n plus 2. So since there are 4 carbons, we have 2 times 4 is 8, plus 2 is 10. Now, this is a helpful starting point, and I think you kind of have to memorize this. As long as it's saturated, and it only has carbons and hydrogens, it will always have this. Whether it's branched or not, we can apply this formula. But as soon as we make an extra carbon-to-carbon bond, like we have in an alkene, or as we do in an cycloalkane, now we're going to get C4H8. And as long as there's that extra carbon-to-carbon bond, it costs us these 2 hydrogens. So every extra carbon-to-carbon bond costs 2 hydrogens. So for an alkene or a cycloalkane, it's CnH2n. And if I make an extra bond here, it's going to be CnH2n, and it's going to cost another 2 hydrogens. But I'd like you to really take in that for any just alkane, the CnH2n plus 2 applies. For any chemical that has an extra carbon-to-carbon bond, they're going to be comparable to other chemicals that have an extra carbon-to-carbon bond. And then if you have a triple bond or a double bond in a cyclo, they both have an extra carbon-to-carbon bond. And we could compare them just by understanding that and having the number of hydrogens available. Now, where this comes up is a question that is like this. It's going to say, list 4 molecules that are isomers of C5H10. As soon as I see this C5H10, this is CnH2n. So we're talking about something that is not an alkane. If it's just a straight alkane, like methylpropane, it's off, because this is CnH2n plus 2, right? And so dimethylpropane, same problem. But ethyl cyclopropane, it has a cyclo, so it's got that extra carbon-to-carbon bond. This is a cyclo, it has an extra carbon-to-carbon bond. This is an ene, so it has an extra carbon-to-carbon bond. But this is an ine. And an ine is going to have the extra one beyond that. So it'll be CnH2n, and then plus 2, minus 1 for the carbon-to-carbon, and another carbon-to-carbon is minus 2. So it will not work. Those ones do not apply. Now, through the process of elimination, I've got the answer for this already. But let's go one step further. This is a pent, so it's C5. So that'll work. C5 with a double bond, H2n. Cyclopentane, pent is 5 carbons, so it's going to be C5H2n. Ethyl cyclopropane. The cyclopropane gives me 3 carbons and 2 more for 1 ethyl. And then methyl cyclobutane gives me 5 carbons. And so my answer here is going to be these, and I can do that fairly quickly by just identifying whether it is got just an alkane, cycloalkane, which has the extra carbon-to-carbon bond, alkene, which has a double extra carbon-to-carbon bond, or an alkyne, which has 2 extra carbon-to-carbon bonds, or a cycloalkene, which has 2 extra carbon-to-carbon bonds. And that's going to help you quickly identify whether things could be isomers or not. And when it comes to identifying the number of carbons, it becomes quite quick. If I have something like 2,2-dimethyl 3-ethyl oct 1, no, it won't be not possible to do oct 1, oct 3 ene. I know that this has got an extra carbon-to-carbon bond, and it's got 8. It has 1 ethyl, so that's 2 more carbons. It has 2 methyls, so that's 2 times 1. So my total is 12 carbons. So it's C12, If it was an alkane, it'd be H24 plus 2, which would be 26. But because it has the extra carbon-to-carbon bond, it's going to be 24. And if instead it was this and it was an ine, so it has a triple bond, this would have been C12H22. And so either the name or the structure is going to allow me to identify isomers quickly. And when they ask you to compare the properties of the isomers, that depends on what kind of isomers they are. You have to be a little careful with alcohols and a little careful with alkyl halides, being able to do the calculation. But most of the questions about isomers, unless they're quite obvious, if they're giving you a list of them, they usually want you to be able to identify just hydrocarbons.